Welcome to Ultrasound Physics Lab Session 4. Today we're going to talk about dynamic range and power Doppler. Let's get to work. I'd like you to take a look at this image right here. It's a liver and a kidney. The image you're looking at right now isn't as good as the image that I can see live. The image that I see live here in the lab has a lot more grays and a lot more subtleties. Why is that? It's because my iPhone camera has a lot lower dynamic range than the display here. That makes the image you see on the video more black and white, more contrasty, with less shades of gray. Which brings us to our first subject today, dynamic range. Let's demonstrate it with a thyroid ultrasound. Okay, let's start a new patient. Okay, the demographics page is up. We're going to do a thyroid, so let's pick small parts. Okay, I see Joe's name is here, so we'll pick that. New exam. Okay, we got Joe on the screen. Save and exit. Okay, it's coming up scrotal. We don't want that. Let's go to a thyroid. Okay, we want the linear probe. Small parts. Go to thyroid. Okay, here's Joe. Have your patient lay back with the head slightly extended. And let's start with the transverse with the notch to the right. Okay, here's the thyroid. We see the jugular vein over there, the right jugular vein getting big. You can compress it. You see the carotid right next to it. There's the right lobe of the thyroid. In the middle is the isthmus. And then here's the left lobe. Okay, so when we picked the thyroid application, it gave me an appropriate depth. It gave me 2 focal zones. You can see on the right side there. And then also down here you can see it gave us 8.5 megahertz frequency and a dynamic range of 66 decibels. Dynamic range, what's that? All the machines have it. They all call it dynamic range, and the units are all decibels. You can even adjust the dynamic range on a frozen image. So what does dynamic range do? It increases the number of shades of gray of the image. So I'm going to turn up the dynamic range, and you get more gray, more subtleties. So why not have dynamic range all the way up all the time? Because you can have the image too gray. You want some contrast. Sometimes you need contrast to see subtle changes in the parenchyma of a liver or a kidney or a thyroid. Another word for dynamic range is compression. Compression is reducing the dynamic range. Dynamic range or compression affects the number of shades of gray displayed and is adjustable. Compression is one of the 5 functions of the receiver in the ultrasound machine, but we're just going to concentrate on the compression right now. The receiver performs 2 types of compression, integral between the components of the machine and operator adjustable. Here we're talking about the operator adjustable compression, which affects the display. So when you perform compression, you're reducing the dynamic range, you're reducing the shades of gray, and it's like contrast. So when you change the dynamic range, you're changing the number of shades of gray in your image. When you lower the number of shades of gray, it's called compression. When you lower the dynamic range, it's called compression. Different application presets give you a different dynamic range. I occasionally change the dynamic range, but generally I just go with what comes up on the preset. Next, we're going to look at power Doppler. The power Doppler knob or button is usually located right next to the color flow button. Here on the GE, they call it PDI for power Doppler imaging. On the Philips, it's called CPA for color power angiography. On the Siemens, they just call it power. It's right next to the color button. On the Toshiba, they just call it power also. Here's a traditional color Doppler. Here's power color Doppler. Here's a thyroid. Here's the thyroid with traditional color Doppler, and here with power color Doppler. The difference between color Doppler and power color Doppler is that in color Doppler, it utilizes the Doppler shift to assign colors, while in power color Doppler, it uses the amplitude of the returning signal, which is directly related to the number of moving blood cells. The big advantage of power color Doppler is its increased sensitivity to low flow. Also, it's not so angle dependent unless you're exactly 90 degrees. And there's no aliasing. The disadvantages are a low frame rate, which gives you poor temporal resolution, no velocity measurement, and it tends to have motion artifact. The uses of color power Doppler are, again, the detection of slow flow, superficial structures, and blood vessels in solid organs. Here's an example of a renal ultrasound using color power Doppler. In my experience, I've used color power Doppler in instances when I couldn't get a good signal with conventional color Doppler. Examples of this are detection of trickle flow in a DVT in a clotted off leg, detection of trickle flow in an obstructed carotid artery that's almost occluded, and detection and comparison of flow in testicular and ovarian torsion when the testicle or the ovary is twisted on its blood supply. One of the disadvantages of power Doppler used to be that it couldn't detect the direction of flow. Newer machines now have directional power Doppler, so that's no longer a problem. You can also get spectral Doppler from a power Doppler image. Okay, that's it for today. If you have any comments or suggestions or criticisms about these videos, feel free to email me at rscott1@nova.edu. Okay, see you next week.